This is example 7. Water 30 centimeter deep is in uniform flow down a 1 degree unfinished concrete slope when a hydraulic jump occurs. If the channel is very wide, estimate the water depth y2 downstream of the jump. So it means that we need to calculate what is the depth of this water after the hydraulic jump. So and then the situation is different from the situation number 1 because this water flow is actually flow with the gravitational force. It means that because we have a slope here, so the water flow at certain velocity. So after the energy increase at certain level means it's become lower and lower, and then it reached the critical point, and then it should it short its pipe, and it will create a hydraulic jump here. Okay, so because from the question, so we have a 1 degree here, so we calculate the tangent of 1 degree, so it is equal 0.01746. And then according to the notes here, it is unfinished concrete slope. So we take the value of n here is 0.014. So this number is come from a table telling the frictional behavior of type of open channel. So and then because we have a hydraulic jump, so we could calculate the value of y2 here by using this equation. So first we need to calculate the Froude number at point number 1. So this is the equation. So we need to get the value of V1. So and then we could get the V1 by calculating using the Manning equation. So and then if you see the situation here, they give you in term of SI units. So means that your Manning equation should be 1 over n. So if the question give in British unit, so you need to use 1.49 over n in your calculation. So here, to get the V1 here, so we need to calculate the hydraulic radius. So the problem is, in this situation, in this condition, they not give us the value of width, because hydraulic radius equation is cross-sectional area over WP, weighted parameter. But it says that the channel is very wide. So what we could make conclusion from that statement is, if the width is too big, okay, it is okay for us to take hydraulic radius equal to real depth. So means that in this situation, because the width is very wide, so we could take the hydraulic radius as 30 centimeter. So we substitute 0.3 meter here. We could get the value of V1. We substitute into this equation. Okay, so we could get the Froude number 1 is 2.466. So mean it's supercritical. So and then means the hydraulic jump will occur. So in this situation, it's occur here. So and then if we substitute in this equation, we found that the value of y2 here is equal to 0.907 meter.